Hi, now examples for geometric progression for J. So calculate the present value X when I is equal to 6%. And the cash flow is this. So we have 5 years, and the T is equal to 0 to 5. And the payment amount is $1.03 at time 1, and 1.03 square at time 2, 1.03 cube at time 3, and 1.03 fourth power and fifth power. So the last payment is a little more than 1.15. So 1.03 to the fifth power. So a little more than 1.15. And I is equal to 6%. And what's the formula to get this? So present value is equal to just a right angle 5, but we have to calculate this J. And what is J? So J is I minus K. So I is 6%, so 0.06, and K is 0.03. You can see that this is 1 plus K. So that means K is 0.03. Then the divided by the 1 plus K, so that is 1 plus 0.03. So this is 0.03 over 1.03. So this is 0.02913 or 2.913%. So a right angle 5 at 2.913%. So if you put in the calculator BA2 plus, then you get this as $4.59. So to get these, maybe the 3 digits correctly, at least you have to take 3 digits for J. Probably the 4 or 5 digits are safer. If J is only 2 digits, the effective digits are only 2 or for J, then of course you cannot get the exact amount. So they just round all quantities at last. Okay, so this is the first example. So now the second example. So calculate the present value X. And here we have slightly more complicated cash flow. So suppose that we have the 10 years. So annuities for 10 years. And 0, 1, 2, 3, up to 10. But the payment amount starts at 100. And the second one is 100 times 1.02. The third one, 100 times 1.02 square. And the last one is 100 times 1.02 to the 9th power. I is 4%. So you can see that the factor is 1.02. So this is 1 plus K. So 1.02 is equal to 1 plus K. So you can see the K is equal to 0.02. But the point is that the first amount is not really 1.02, but the first amount is actually the 100. So how to calculate this? And to evaluate X, we have to have the same shape. So it has to start at 1 plus K. So we think about, okay, so 100 is fine because everything is 100 times larger. But this, we don't have 1.02 at time 1 is problematic. So we think about 1.02 times X. So present value of is X, and we think about 1.02 times X. Then, so this coincides with the cash flow of 100 times 1.02 at 1, 100 times 1.02 square at time 2, and 100 times 1.02 cube at time 3, and so on. And the last payment is 100 times 1.02 to the power 10. So in this way, we can apply the previous formula. So now that we have 1 plus k, square of 1 plus k, cube of 1 plus k, up to the nth power of 1 plus k. So now that we can get the 1 plus 1.02x is equal to a right angle 10 at j. And here j is the I minus k, so I is 4%. So I minus k over 1 plus k. Yeah, and the k is 0.02 and the I is 0.04. So 0.02 divided by 1 plus 0.02. So this is slightly smaller than 2%. And actually, this is 0.01961 or 1.961%. So this is equal to, this is 100 times. So this is 100 times. So this becomes 900.1. 900.1. So what is x? X is equal to this divided by 1.02. So we get this as 882.46 cents. So maybe we only have 4 digits here. So maybe only the 882 is valid, but this is approximately $882. Yeah, so the point in this second example is that if a cash flow that starts with $1, not 1 plus k, then we have to divide the amount by 1 plus k at last. So at first we have to calculate 1 plus k times x, then we divide the, both sides by 1 plus k. Then we get the answer.